Hi guys, welcome to my channel. In our last class, we saw how this Maclaurin series formula was derived. So in today's class, we're going to be using this Maclaurin series formula to find the series of the following functions. Now, we're going to be working on these exercises. Number one says, express the following as an infinite series in ascending power of x. And number two says, find the first four terms in the Maclaurin series of these two functions we have here. Now, let's start with number one. Number 1a to be precise. So this is the question we have. The question says, express the following as an infinite series in ascending power of x. So we're going to be expressing this using the Maclaurin series. So what we'll have here is the natural log of 1 plus x. The first thing we have to do is to call this a function of x. Yeah, it's a function of x. So this is equal to natural log of 1 plus x. Now, the next thing we have to do is to find the first derivative. So which is f prime of x. So the first derivative of this, if we can remember, the natural log of x, the derivative is 1 over x. Whenever we have the natural log of x, the derivative is 1 over x. So in this case, the derivative is 1 over 1 plus x. So we can as well write this as 1 plus x to the power minus 1. So it will be easy for us to, differentiate. Instead of using the quotient rule, we can just use the chain rule to solve this. So now the next one is the second derivative. We have f prime prime of x, which is equal to, so working with this, we can see we have a power minus 1 here. So if we're going to be working with the derivative formula, this is going to give us minus 1 times the function 1 plus x raised to power. Minus 1 gives us minus 2. Yeah. So you have to remove 1 from the power. Let's not forget that. So if we are to use the chain rule, we are also meant to find the derivative of x so that we'll multiply it by this. Now the derivative of x here is 1. So multiply this by 1, you still get whatever you have there. So there's no point doing that. We can just stop our work here. So now we've been able to get the second derivative. Let's find the third derivative. So for the third derivative, we'll be having, this is minus 2 here. So minus 2 times minus 1, that should give us, okay, let's just write it, minus 1 and then the power minus 2. Then we have the function 1 plus x raised to power minus 2 minus 1 gives us minus 3. So this is minus 1 times minus 2 is positive 2. So we just have 2 brackets 1 plus x raised to power minus 3. Now let's find the fourth derivative and probably we'll stop here. So for the fourth derivative, we'll have 2 times minus 3, then 1 plus x raised to power minus 4. Okay, 2 times minus 3 is minus 6, so we'll have minus 6 bracket 1 plus 6 power raised to power negative 4. So if you remember what we did in our last video when we were deriving the Maclaurin series, is that after getting the successive derivatives, the next thing is to make x 0. That's substitute x to be equal to 0. So in that case, if we are to substitute x to be equal to 0, we'll start from here. This gives us f of 0, which is equal to the natural log of 1 plus 0, which is equal to the natural log of 1. And then the natural log of 1 is 0. Now we'll move to the next one. We'll have f prime of 0. This is going to be equal to, we'll have 1 over 1 plus x. So let's take note that we are meant to remove this one because we use this for the second derivative. Okay, so now let's say we have so we can actually work with 1 plus x raised to power minus 1. So which is going to give us 1 plus 0 power minus 1, which is equal to 1 raised to power minus 1. So it's actually 1. 1 raised to power minus 1 is 1 over 1, so it is 1. So now for the second derivative, when x is equal to 0, we'll have f prime prime of 0, which is going to be equal to minus 1 bracket 1 plus 0 raised to power minus 2. So this is equal to minus 1 raised to power 1 raised to power minus 2. So 1 raised to power minus 2 is 1, but then we'll have 1 times minus 1, which is equal to negative 1. Now to the third derivative, when x is 0, we'll have f prime 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 of 0 is equal to 2 times 1 plus 0 raised to the power minus 3. This is equal to 2 times 1 raised to the power minus 3. 1 raised to the power minus 3 is 1 times 2 will have the value 2. Now we'll move to the fourth derivative. When x is 0, this is minus 6, 1 plus 0 raised to the power minus 4. This is minus 6, 1 raised to the power minus 4. So 1 raised to the power minus 4 is 1. Then times negative 6, we'll have negative 6 as our answer. So like I said, we'll have to stop here. The question says, express natural log of 1 plus x as an infinite series in ascending power of x. Ascending power of x meaning we'll have to start from degree 0, 1, 2, 3. So we can stop at 4 and then we'll have our infinite and the dots representing that it is actually going to infinity. So meaning it's an infinite series. So now that we've been able to get the successive derivative and substituted x to be equal to 0, so we have to substitute these values into the Maclaurin series formula. So we can remember the Maclaurin series formula as f of x equal to f of 0 plus f prime of 0x plus f prime prime of 0x squared. This is over 2 factorial plus f prime 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 of 0x cubed over 3 factorial plus fiv of 0 x raised to the power 4 over 4 factorial. So dot dot dot, which shows it's going to infinity. Now, for the Maclaurin series of the natural log of 1 plus x, f of x is going to be equal to, for f of 0, we got f of 0 to be 0. So we have 0 plus, now f prime of 0 is 1. So we have 1x plus f prime prime of 0 is negative 1. So over 2 factorial x squared, then plus f prime 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 of 0 give us 2. So we have 2 over 3 factorial x cubed, then plus fiv give us negative 6. So negative 6 over 4 factorial x raised to the power 4. Then we have plus dot dot dot. And this is equal to 0 is gone. So x minus 1 over 2 factorial is 2. So then we'll have x squared here plus 2 over 3 factorial is 6. That's 3 times 2 times 1. So 6, then we'll have x cubed minus 6 over 4 factorial is 24. That's 4 times all of this. So 24 x raised to the power 4 plus dot dot dot. So now we have to break it down to simplest form. So this is x minus, we could just do x squared over 2 plus 2 here 1, 2 here 3. So that's x cubed over 3, 6 here 1, 6 here 4. So minus x raised to the power 4 over 4 plus dot dot dot. So if we can actually look at this very well, we can see there's some sort of pattern. That's if we put over 1 here, so we see that the denominator is increasing like successively, like 1, 2, 3, 4. And then the numerator, the power of x are also increasing. 1, 2, 3, 4. So we can actually express this natural log of 1 plus x in compact form, that's in general form. We can decide to do that by saying, okay, since we have f of x, so f of x is equal to what? F of x is equal to the natural log of 1 plus x. So to express this in compact form, we have to take note of some things here. The denominator is going from 1, 2, 3, 4. So if you see this is sequentially, so after 1 we have 2, after 2 we have 3, after 3 we have 4. And also the same thing happens to the power of x, 1, 2, 3, 4. So we can say this is summation, okay? R should start from 1 to infinity because this is actually going to infinity. Now R is starting from 1. We cannot say 0 here because there is nothing starting from 0 here. So now for the denominator, let's fix the denominator. The denominator should be R. So for the first step, if R is equals to 1, the next sum is 2, the next sum is 3 until we get to infinity. Now the numerator is going to be x raised to power R because R is going from 1 to infinity also. So the first one is going to be x raised to power 1, the next one is x raised to power 2, and so on. Now the next thing we need to look out for is the signs. For the first variable, there's a plus sign here. Here there's a minus, here there's a plus. Here there's a minus, there's a plus, there's a minus, there's a plus. So the signs are actually alternating. Now for we to fix this, we can say that this should be, let's say, minus 1 to the power something. So it has to be the power of r. But if we choose r and then we say when r is equal to 1, this is going to be minus 1 raised to power 1. Then it means the first stage is going to give us minus 1. But that's not it. What we have here is plus. And if we say we should put 2, minus 1 raised to power 2 gives us 1. Meaning that when r is 2, we're going to be getting a plus sign here. So this won't work. We could probably say let this be minus 1 to the power r plus 1. So when r is equal to 1, it will be 1 plus 1, which is 2. So minus 1 raised to the power 2 gives us a positive sign here. Now when r is 2, we could say 2 plus 1, which is 3. Minus 1 raised to the power 3 gives us minus, so which is actually going to solve this problem. So for this case, it's going to be minus 1 to the power r plus 1. So the natural log of 1 plus x in compact form is summation r equals to 1 to infinity. Then we have minus 1 to the power r plus 1 all over r, then x raised to the power r. So if we fit in the values of 1, 2, 3, 4, we'll be able to get f of x equal to x minus x squared over 2 plus x cubed over 3 minus x raised to the power 4 over 4 plus dot dot dot. Now that was all for this question. Let's move to question 2. So for question 2, we have exponential x. Now for question 2, we have f of x is equal to exponential x. Just like we did with the previous question, we have to find the successive derivative. Now f prime of x is equal to, here we are differentiating exponential x. For we to differentiate exponential x, we have to differentiate the value of x, then whatever we get, we multiply it by the function. So the derivative of x is 1 actually. The derivative of x is 1. So 1 times exponential x is exponential x. So the derivative of exponential x remains the same. So this is going to give us ex. F prime prime of x is also going to give us exponential x. F prime 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 of x is also going to give us exponential x. And we take it to the fourth derivative, it's also going to give us exponential x. So I can just decide that we stop here. Now, let's substitute when x is 0. So f of 0 is equal to exponential 0, which is 1. F prime of 0 is equal to exponential 0, which is also 1. F prime prime of 0 is equal to exponential 0, which is also 1. So let's just write the answers down since we know what it is. So we have f prime prime of 0, exponential 0 equal to 1. Fiv of 0 equal to exponential 0 equal to 1. Okay, now we've been able to get the values for the derivative when x is equal to 0. So the next thing is to substitute them into the Maclaurin series formula. So I'm not going to write the Maclaurin series formula again. We know it. So we'll have f of x is equal to f of 0, 1 plus f prime of 0x, so which is 1x plus f prime prime of x and of f prime prime of 0x squared over 2 factorial. So that should give us 1 times x squared over 2 factorial plus 1 times x cubed over 3 factorial plus the fourth derivative 1 times x raised to the power 4 over 4 factorial plus dot dot dot. This is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x raised to the power 4 over 4 factorial plus dot dot dot. So this is our answer. This is the series of exponential x. This is a series of exponential x. So just like we did with the natural log of 1 plus x, we can also keep this answer in compact form, or we can actually say the general term. Now, f of x, which is equal to exponential x, is equal to, now we'll start with the summation. So if you look at the denominator is going, okay, let's call this 0 factorial. Let's call this 1 factorial. Then let's call this 1 here x raised to the power 0. So because x raised to the power 0 is 1. So you can see this is going from 0, 1, 2. There will be a power 1 here. So this is going from 0, 1, 2, 3, 4 down to infinity. So likewise the denominators too. So we can say the denominator, okay, now arrow should go from 0 to infinity. I think we've seen how that came about. Then the denominator is going to be arrow factorial because there's a factorial for the denominators, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, down to infinity factorial. Now for the numerator, we'll have x raised to power r. So that when r is starting from 0, we'll know that x raised to power 0 over 0 factorial, that's 1 over 0 factorial. 0 factorial is 1, so which is 1. Then the next stage, and the next step is going to be x raised to power 1 over 1 factorial. The next is x squared over 2 factorial. So this is actually the compact form for this question. Now for question 3, it says we should find the series of exponential negative x. Now I wouldn't want us to start differentiating one at a time again, like finding the successive derivative for exponential negative x, when we already have exponential x. We already have the series of exponential x to be. We already have the series of exponential x to be this. So what we're going to do is we're going to substitute. Anywhere we see x, we put negative x. Now let's start that. Question 3. So we're given exponential negative x. Okay, my bad, I'm numbering this wrongly. It should have been 1a, this should be 1b, and this should be 1c. So let's fix that. So 1c will be equal to exponential negative x. That's the question, is exponential negative x. So meaning that f of x is equal to exponential negative x. So just like I said, recall exponential x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x raised to the power 4 over 4 factorial plus dot dot dot. I'm going to put an instruction by saying replace x with negative x. So anywhere we see x, we put minus x. Now we're going to be having exponential negative x to be equal to 1 plus what we have there, x, that becomes minus x, plus negative x squared over 2 factorial plus negative x cubed over 3 factorial plus negative x raised to the power 4 over 4 factorial plus dot dot dot. So I wanted to know that if you also use the successive derivative method and substituting x to be equal to 0, you will still get this answer. You'll still get it, but why do that when we already know exponential x? Okay, so moving forward, we have this should be equal to 1 minus x plus negative x squared is x squared. Yeah, we have negative x times negative x, minus times minus is plus, x times x is x squared. So if we have one more times minus x, which is going to be negative x cubed. So we'll see that minus times minus is plus, plus and minus is minus. So for the cube, it's going to give us a negative. So this is 2 factorial. So for the cube, just like we just explained, minus x cubed over 3 factorial. Then for the power 4, it's going to be plus x raised to the power 4 over 4 factorial plus dot dot dot. So this is our answer for exponential minus x. So for exponential minus x, we have 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x raised to the power 4 over 4 factorial plus dot dot dot. Now, the compact formula is actually going to look like the general formula because we have power 1 here, 1 factorial, then this is 0 factorial, and then this is x raised to the power 0. It's going to look alike. The only difference is the sign changing. At this point, we'll have a plus sign, we'll have minus here, plus, minus, plus, minus, plus, minus. The signs are alternating. So we have that f of x, which is equal to exponential negative x, is going to be equal to, if I write this in the general formula, r is going from 0 to infinity, then we have over r factorial x raised to the power r. So the issue now is to fix the sign. So we're having negative 1 power r. Let's just try negative 1 power r and see what it gives us. So when r is 0, we'll have negative 1 raised to the power 0, and anything raised to the power 0 is 1. So I think that fits the sign there, which is going to give us a plus sign. Now, the next one will have negative 1 raised to power 1. So minus 1 raised to power 1 is minus 1. So which is going to fit this minus sign here. Then the next one is minus 1 raised to power 2. Minus 1 raised to power 2 is plus 1. So it's going to fit this sign. So this fits it. So we'll have negative 1 raised to power r. So the general formula for exponential negative x is summation r equal to 0 to infinity, negative 1 to the power r, x to the power r over r factorial. So this is it with this question. Now we need to move to question 2. So let's check. Question 2 says, find the first 4 terms in the Maclaurin series of sine x and cos x. Now, in this particular one, it said find the first 4 terms. So, you know, the other ones we've been working on, I think we've been taking them to the 5 term because we'll have, let's count, we'll have 1, 2, 3, 4. Okay, this is the first 4 term. Let's see the next question. 1, 2, 3, 4, 5. Okay, this is the first 5 term. So, but for the sine x and cos x, we're strictly told to find the first 4 term. Now let's start. 2a. So for 2a, f of x is equal to sine x. Now, successive derivative. F prime of x is equal to cos x. Yeah, if you know the derivative of trigonometry, it is derivative of sine x is cos x, derivative of cos x is negative sine x. So that's what we are going to be applying here. So derivative of sine x gives us cos x. Now we have to find the second derivative. So if we differentiate cos x, it gives us negative sine x. Now the third one, this is going to be, the minus should stay. Now let's differentiate sine x. Derivative of sine x is cos x, okay? Now the fourth derivative, this is equal to, we'll keep the minus. The derivative of cos x is minus sine x. Now minus times minus gives us plus. So let's get rid of this and just write sine x. Alright, so the fifth derivative of x is equal to cos x. So we can see that it is now repeating from this. So we can just write our answers from there. Now the sixth derivative of x is equal to negative sine x. Let's take it to the seventh derivative because I feel the seventh derivative. So this should give us minus cos x. I hope you can see what I'm doing, just repeating the pattern we'll have from here. So let me remove this. Now we'll be wondering, how come we've differentiated down to the seventh derivative, but the question says find the first 4 terms? It is pretty simple. If we start substituting x to the 0, and then we put sine 0, which is sine x, sine 0. Sine 0 is 0. So meaning that that term is cleared. So if we are trying to write the series, the part of 0 will be removed. So that way it will reduce the term we'll have left. So if we are working up to the seventh derivative, I believe by the time some zeros are gone, we'll be left with the 4th term we are asked to find. Now let's start substituting x to be equal to 0. So we have f of 0 is equal to sine 0. Just like I say, sine 0 is 0. You can punch this in your calculator. So f prime of 0 is equal to cos 0. Cos 0 is actually 1. Now we'll have f prime of 0 equal to minus sine 0, which is also 0. F prime of 0 equal to minus cos 0. This is going to give me negative 1. Now, FIV of 0 is equal to sine 0, which is 0. The fifth derivative of 0 gives me cos 0, which is 1. Then the sixth derivative of 0 is minus sine 0, which is 0. And then the seventh derivative of 0 gives me minus cos 0, which is minus 1. So we can see we have how many terms here? 1, minus 1, 1, minus 1. We are left with 4 terms because the answers with zeros are definitely going to be gone. So now, let us start substituting this into the Maclaurin series formula. So, f of x is going to be equal to f of 0 is 0 plus f prime of 0. F prime of 0 gave us 1. So which is going to give us 1x plus f prime prime of 0 give us 0. So 0x squared over 2 factorial plus f prime 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 of 0 will give us minus 1. So minus 1x cubed over 3 factorial, then plus the fourth derivative is 0 x raised over 4 over 4 factorial, plus the fifth derivative is 1 x raised over 5 over 5 factorial, plus the sixth derivative is 0 x raised over 6 factorial, and the seventh derivative is minus 1 x raised to power 7 over 7 factorial plus dot dot dot. Okay, so we can actually just confirm our answer. So we can see 0 1 0 minus 1 0 1 0 minus 1. So that's very correct with what we have there. Now f of x is equal to, we can see this is gone, this is gone, this is gone, this is gone. We are left with x minus x cubed over 3 factorial plus x raised to the power 5 over 5 factorial minus x raised to the power 7 over 7 factorial plus dot dot dot. Okay, just like we've been doing for others, I would love us to keep our answer in a compact form. This is sine x, so we're trying to work on the summation. R will be equal to what? We don't know, but it's going to infinity. So the denominator, we're going to fix that also. But now, there's a pattern here. We'll have 1 factorial here to the power 1. So we can see these are odd numbers. We'll have 1, 3, 5, 7, 9, 11, so on and so forth. The same thing applies to the numerator. The numerator will have the powers of x to be 1, 3, 5, 7, 9, and so on. So now, if we are to express numbers in like odd form, like what way can we write numbers that are odd? So we could probably use the sequence method to get the term for odd numbers. So if we have our numbers ranging from 1, 3, 5, 7, so we can say the first term is 1, the second term is 3, the third term is 5, the fourth term is 7. Now, I could decide and say, okay, for sequence, how do we express odd numbers? If we try 2n, 2n is not going to work because anytime n is 0, 2 times 0 is 0. Now, if n is 1, 2 times 1 is 2. If n is 3, 2 times 3 is what? 6. But then we could use 2n plus 1. Let's try this. Now, if n is 0, we'll have 2 times 0 plus 1, which is equal to 0 plus 1, which is 1. Now, if n is equal to 1, 2 times 1 plus 1, 2 times 1 is 2 plus 1, gives us 3. We could try n is 2 plus 1. So 2 times 2 is 4. 4 plus 1 is what? 5. So we've been able to use this to get the odd number. So the denominator is 2n plus 1 factorial. Because we've seen how this particular sequence formula was able to give us the odd number 1, 3, 5, 7, 9, and so on and so forth. So if we can do this like this, so meaning the power of x is also going to be in the odd form. So x is going to be, sorry, we should be using arrow here. So don't mind that I use n there. So 2r plus 1 factorial. Okay, so x is going to be 2r plus 1 because the x is also in odd term. So the next thing is the sign, it's alternating. So just like we did with the other one, we can see that the first one is positive, the next one is negative, the second one, like the third one is positive, negative. So I think this should be minus 1 raised to power r. So r is definitely going from 0. We saw what we did with the sequence. So if r is 0 here, minus 1 raised to power 0 gives us a plus sign here. If r is 1, minus 1 raised to power 1 gives us a negative sign here. If r is 2, minus 1 raised to power 2 gives us a positive sign here. So we can see this actually works. Now let's go to the last question, which is 2b. It says we should find the Maclaurin series of cos x. Now for 2b, f of x is equal to cos x. Alright, so just like we did with the sign, we have to find the successive derivative. So the derivative of cos x is negative sine x. The second derivative is going to give us negative cos x. The third derivative is going to give us negative. Then cos x is minus sine x. So this should give us positive sine x. The fourth derivative is going to give us cos x. So see, we'll start repeating from here. The fifth is going to give us minus sine x. The sixth is going to give us minus cos x. I think we can stop here because if we start substituting x to be 0, the cos x are going to give us values, so which is actually enough for the fourth term. So I hope we can see it here. We have term 1, term 2, term 3, term 4, because it says express for the first four term. I hope we get that, because it says it said find the first four terms in the Maclaurin series of then the functions given to us. So the same thing is going to apply here. Now let's start substituting. F of 0 is equals to cos 0 equal to 1. F prime of 0 is equal to negative sine 0 equal to 0. F prime prime of 0 is equal to negative cos 0, which is minus 1. F prime 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 of 0 is equal to sine 0, which is equal to 0. Fiv of 0 is equal to cos 0, which is 1. Fb of 0 is equal to minus sine 0, which is equal to 0. Fvi of 0 is equal to minus cos 0, which is minus 1. So we've been able to obtain term 1, term 2, term 3, term 4. Okay, this works for us. So let's start substituting the value into the Maclaurin series formula. We have f of x is equal to f of 0, there is 1. So 1 plus f prime of 0 is 0. So f prime of 0 is 0, which is going to give us 0x, plus f prime prime is negative 1, x squared over 2 factorial. Then the third derivative is 0. We have x cubed over 3 factorial. The fourth derivative is 1, x raised to the power 4 over 4 factorial. The fifth derivative is 0, 0x raised to the power 5 over 5 factorial. The sixth derivative is minus 1, x raised to the power 6 over 6 factorial plus dot dot dot. So let's confirm that we have 1, 0, minus 1, 0, 1, 0, minus 1, 1, 0, minus 1, 0, 1, 0, minus 1. So the zeros will be eliminated. So we have f of x is equal to 1 minus x squared over 2 factorial plus x raised to the power 4 over 4 factorial minus x raised to the power 6 over 6 factorial plus dot dot dot. So this is the first four term. 1, 2, 3, 4. This is the first four term. So just like every other question we've been working on so far, we would like to express this in the compact form. Now, f of x, which we know is cos x, is equal to, let's have our summation. Now, let's call this over 0 factorial, and this should be x raised to the power 0. Okay? So let me write this in a different color of pen. So, okay, x raised to the power 0 over 0 factorial. Now we can see that the denominators are even numbers, and also the powers of the x are also even numbers. So for even number, we can use 2n. Let's try. Now when n is 0, we'll get 2 times 0 to be 0. When n is 1, we'll get 2 times 1 to be 2. When n is 2, we'll get 2 times 2 to be 4. So we can see this is 0, 2, 4, 6, 8, 10. These are even numbers. So we can say let r start from 0 to infinity all over 2n factorial. Yes, 2n factorial, then x to the power 2n. So this is for the numerator. The powers of x are even. Now the sign also alternating, plus minus plus minus plus minus. So let's here be minus 1 to the power r. So far, we've been able to answer the 5 questions given to us here. We can see for question 1, we have 3 functions. For question 2, we have 2 functions. This gives us 5 questions, or we say 5 functions. Yeah, we've been able to find the Maclaurin series of 5 functions. If you're able to stay to this point, thank you very, very much for your time. And if you're a first timer, I hope you enjoyed this video. So do well to like, subscribe, and share this video to your friends who might actually be needing help with the Maclaurin series expansion. So see you in my next video. Bye.